So, good morning, everybody, and welcome to a Monday morning pre-calc class. So what we're going to do is we're going to expand our understanding of transformation. Last week we did the translation moving up or down, left and right? So today what we're going to do a horizontal and vertical, but this time is stretches and compression. And then actually I want to add something in here, and reflection. Okay, so if you want to have a complete description of what we're going to do, we're also going to do reflection. Reflection on in the x-axis and the y-axis. So let's get started. For a function y equals to f of x, okay, looking at that one, the specific function is not given. They call it f of x, right? A vertical compression or stretch of a function is defined by the equation y equals a times f of x. So this a value here, the a value tells us compression, stretching, or compression. Vertical compression or stretching. So it says here, if the absolute value of a, what does absolute value of a means? We're only going to take a positive value of a, right? Is between 0 and 1, there's a compression, right? So if its absolute value of a is between 0 and 1, okay, think of between 0, can you think of a number between 0 and 1? 0.5, right? Okay, if it's 0.5, we're going to have a compression by a factor of absolute value of a. Can you give me another number between 0 and 1? Negative 0.5, okay, yeah, it would be absolute value of negative 0.5. It's also still positive 0.5. Positive 0.75. So anything that's between 0 and 1, we're going to have a compression. Oh, vertical compression. Vertical. Now, here we go. If the absolute value of a is greater than 1, okay, think of a number that's greater than 1. 2, 3, 1.5, right? 2.3, 2.5, okay, well, that's not a problem, right? If a is greater than 1, there's a vertical stretch by a factor of absolute value of a. And then if a is less than 0, less than 0 means negative, right? When it's negative, then there's a reflection in the x-axis as well as a stretch or compression. Okay? So there's a reflection on the x-axis. Now, I just want to talk about that for a second, and I'm going to show you something about. This is something that you've done already in grade 11, and so when you have something like this, okay, so this is a quadratic function, okay, everyone seems to be familiar with this. This is what the graph looks like. Now, what if we stick a negative at the front? What happens? It opens down, okay? So here, you actually don't call it, a transformation before, okay? But that one is a negative 1, telling us that it's a vertical reflection. Vertical reflection. Where's the reflection coming from? On the x-axis, right? So this is like your mirror, and then this is your reflection. Okay? Good. Good. That's the a value. Now, what about this one? For a function y equals to f of x, again, it's a general function. We don't know what that function is. We call it f of x. A horizontal stretch or compression is defined by the equation y equals f of b times x. So looking at this one here, it's affecting the b, right? It's affecting the b times x. And what does it say? If absolute value of b, if the absolute value of b is between 0 and 1 again, okay? Think of a number that's between 0 and 1. 0.5, okay? If it's between 0 and 1, there is a horizontal stretching, okay? By how much? By a factor of 1 over b, 1 over absolute value of b. Okay? I'm going to summarize this in a second. If b is greater than 1, okay, give us a number between greater than 1, would be a 2. Okay, if it's greater than 1, this one here is a horizontal compression. Now you're thinking, oh, if it's greater than 1, it's going to get compressed. Okay, by how much? By a factor of b, 1 over b. And if b is negative, there is also a reflection in the y-axis. So there's a reflection in the y-axis. I'll give you an example of that. Y equals to square root of x. Okay, you remember how that looks like? Looks like this. Okay, now if we go y negative x, it's gonna, the reflection is gonna be on the y-axis. Now it's gonna be, okay. I bought this pen on the weekend and I'm quite pleased with it. It's going this way, reflection over the y-axis. Okay, so that's what we're going to do today. Okay, so let's kind of summarize all of these things. Let's put it in kind of a writing. Okay, so here, in terms of a mapping purposes, because we've been using mapping. Okay, this is what the mapping looks like. Starts with the x and the y. Okay, and it's going to be 1 over b times x, comma. So that's what's happening. That's a transformation, stretching or compressing on the x, and y, a times y. That would be the stretching or compressing vertically. Okay. Now you're probably thinking, okay, this is just a general thing. I think it's good if we have an example. Okay, so this is what we're going to do. A comma, because this is the x, and then this is the y. Coordinate points, comma, and this is comma too. Okay, so I think let's give it a try. Okay, given the graph of y equals f of x, okay, again, that's a standard or general function. We don't know what the specific function is. We don't know the specific equation that describes this function. We kind of have an idea. But it says here, sketch the graph of y equals 2 times f of x. Okay, so y equals to a times f of b times x. Okay, that's the form, okay? So let's rewrite that. Y equals to, A is 2, f times, what's the b in here? 1. 1x, oh, okay. So A is equal to 2, A equals to 2, and B is equals to 1, okay? What does the A mean? If A is, okay, if absolute value of A is greater than 1, then there is a vertical stretch by a factor of that. So this is greater than 1, yes? Yeah. So in this case, we want to develop a vocabulary, a way to say this. There is a vertical stretch by a factor of 2. There's a vertical stretch by a factor of 2. Now this one here, because it's 1, there's nothing yet, okay? We're gonna actually start with the vertical first, instead of both, okay? So let's do the mapping. X, Y, okay, X, Y. That's the original graph before transformation happened. And this one is going to give us 1 over bx, comma, a times y. Okay, that's the transformation that we're doing. What's the b? It's 1. So it's basically 1 over 1 times x. It's just x. Is that okay? So nothing is happening with the x. But what about the y? A is 2, so it's going to be 2 times y. So 2 times y. Okay, so that's our mapping. Let's pick a point first here. So this is a point here. -3, 0. And then I see another nice point there. It's -2, 1. And what's the other nice points here? 1, 2, and 6, 4. 1, 2, 6, 4. Okay. Oh, 6, 6, 3. Thank you. 6, 3. Thanks, Ivy. 6, 3. Okay. Good. Now we're going to use the mapping here to see the new set of points. So whatever the x is, nothing changes on the x. So it's just going to be -3. And then it's going to be 2 times y. So 2 times 0 is 0. The x stays the same. And then 2 times the y, which is 2 times 1, is 2. Okay, 1. And then 2 times the y, which is 2 times 2, is 4. And then the next one would be 6. And then 6. Okay, so what would that look like on our graph? What does a graph look like now? So it becomes -3, 0. So that's the same point there. -2, 2. So that's that one right there. And then 1, 4. So 1, 4. That's that one there. and then 6, 6. So 6, 6 goes to that corner. That's our line, our curve rather. So our curve, as you can see, this is, think of a rubber band. So I'm like holding on to this, on the x-axis, and I'm stretching it by a factor of 2. Okay, do you see that? Is that good? So this is the transformed. Now, what is the domain? So we've graphed it. Now what's the domain and what's the range? What's the domain and what's the range? So domain would be, what's the domain of this graph? Yeah, state the domain and range of the transformed function. So transform. Okay. Sorry, what did you say again? -3 to positive infinity. Okay, it includes a -3, so we have to put a square bracket, so -3 up to infinity. Yes? And round brackets there. What about the range? Yeah, including the 0 up to positive infinity. Okay, good. Okay, now, I know this is not being asked, but I'm going to show you something before I move on. Look at the domain and range of this initial one. What's the domain and range of that one? Domain is -3 to infinity, and range is 0 to infinity. Okay. Now, what we did, the kind of transformation we did was a vertical stretch. So think of this as the domain stays the same, right? Nothing changes on the x. But there's a vertical stretch by a factor of 2. Okay, so what they're saying is whatever the x values are, it's being multiplied by 2. So if I multiply this by 2, and I multiply this by 2, 0 times 2 is still 0. And if I multiply infinity by 2, it's still going to be infinity. So 0 to infinity still. Okay? So far so good? Is that okay? So we're actually going to take a baby step here. We're going to focus just on vertical stuff for now. And then we'll do the horizontal later. And then we're going to do the mix. Oh no, because the domain is not being affected, right? There's no vertical stretching in the domain. Yeah, yes.
When it says there's a vertical stretch by a factor of 2, that's giving us A, right?
Yeah, giving us the A value. Yeah, correct. Because A is something that's vertical. A is vertical, and then here the B is the horizontal. Okay, good.
Something that it doesn't say here, would you say too that if A or B is equal to 1, then there's no transformation?
Yeah, no. It's just like multiplying this something by 1. It doesn't change anything. Yeah. Yeah, I think examples 1, 2, and 3 are all vertical stuff. We'll start with vertical first, and then we'll move on to horizontal.
So this line now is a vertical straight.
Yeah, vertical stretching. You're stretching like a rubber band. Earlier, I said earlier, like this is your rubber band, you're vertically stretching it. Stretching, okay? So it kind of looks like this is your rubber band, and then you're vertically stretching it. Good? Now let's take a look at the next example. It's better when we have an example. Okay. So example number 2. Given the graph of y equals to f of x, okay, again, some general form of function. It says here, sketch the graph of y equals to 1/3 times f of x. So we have f of, start with y. Y equals to a times f of b times x. Okay? That's a general form. That's the stretching vertically or compressing. And then the b is the horizontal, stretching or compressing. Let's rewrite that over here. So y equals to 1/3 f of b. B is 1x, so just x then, okay? So that, if you multiply something by 1, it doesn't really change anything there. So this one, what does that say? A is 1/3. Okay, what does A is 1/3 mean? Let's go flip it to the first page. If absolute value of A is between 0 and 1, okay, 1/3 is between 0 and 1, yes? So there we should be expecting a vertical compression by a factor of 1/3 in this case. So let's write down the words. There is, okay, so this one, there is a vertical compression by a factor of 1/3. Factor of 1/3, it means we're going to multiply by 1/3 each time, okay? The vertical, which is the y's. So let's do the mapping. Starts with xy. So x, so I'll just write it down here. A is 1/3 and b is equals to 1. So if what we need to do is, it's going to be 1 over b, which is 1, times x, which is x. And then the y would be 1/3 times y. Okay, is that good? So vertically compressing by a factor of 1/3. So let's pick a point here again. On the original graph, I can see 4 points there. So negative 1, 1. 2, 3. Yeah, 2 and then 3, and then the other one is 4, 1. 4, 1. And then the next one is 6.
What about 3, 2? 3, 2, yeah.
Oh, right here. You said 3, 2 right there?
Yeah.
Oh, okay. Yeah, we could do that too. Yeah, I was focusing on the big dots. Okay, but yeah, that's a good one too. Yeah, let's put that in. Let's go 3, 2. Correct.
6, 6.
And then 6, 6. Good eye. I didn't even look at that one. My eyes kind of focus on the big dots there. Okay, good. Okay, so it looks like there's nothing going on with the x, no compression or stretching there, but only the y. Okay, so the x stays the same, so I'll just write down all my x's right now. Okay, so I just recopied my x's, and then now the y's. All my values are being multiplied by 1/3. So it's going to be 1/3 times 1, it'd be 1/3. 1/3 times 3 is 1. 1/3 times 1, which is 1/3. 1/3 times 2, 2/3. And then 1/3 times 6 would be 2. Okay, so now these are the new points. Okay, remember this is gonna be starting to get compressed vertically, so it should be compressed. So let's go ahead and graph it. So -1, where would that be? -1 1/3 would be like right there, right? Okay. So cutting it into thirds, so there's 1/3 there. 2 1, so 2 1. 4 1/3, so 1/3 right there. 3 3 2/3, so this is 1/3 2/3, that's that one right there. And then 6 2, so 6 2. So what does that picture look like? I'm gonna use a ruler. If you need a ruler, I have some at the front. You can help yourself. I'll just put them over here. So now it looks like it got squished. It's compressed. So this one got like squished down. That's what it would look like now. Okay? So far so good. We're only focusing on the Y, compression and stretching. Any questions there? You okay? I think that's the only thing that we gotta do. They didn't ask us for anything else. It just says sketch it. Okay, we did. And that's good. Oh, are you still looking at it? Oh, where's the 3 2/3? So this is gonna be 1 2 3, and then 2/3 would be there. 2 divided by 3 is 0.66 repeating, so it's right there. Yeah, you okay? I gotta be careful in here because there's no arrow going anywhere, so I'm just gonna put dot and then dot. Okay, no arrow because the original function didn't continue on. Okay, good. Now take a look at example number 3. Okay, this one here, they just gave us a point. Determine the coordinates of the image point after a vertical stretch or compression. Okay, so let's take a look at the A. The point A is 3 14. Lies on a graph of y equals to f of x. What are the coordinates of its image A prime on the graph of y equals to -5 times f of x? So what's really happening there is what? So our A value is -5, right? Our A value is -5. The negative tells us there's a vertical reflection. So the negative here gives us a vertical reflection in the x-axis. So it looks like your x-axis will become like a mirror, so it reflects onto that one. Okay? And because this is a 5, absolute value of A and a vertical stretch by a factor of 5. Okay, so there's both a reflection in the x-axis and a vertical stretch also. Okay, so this is the xy, 3, 14. Now we're going to do the image. Because this is a vertical, the A, so the x stays the same. And what happens to the y? Becomes -5 times 14. So it's -70. -70. So this is going to be x, comma, a times y. A times y. What's our a? Our a is -5. So a, -5 times the y value of 14, so -70. Yeah? Did I do it wrong? 5 times -14 is -7.
You see the minus is reflection, right?
Yeah.
But still you're going to use when you multiply or
Mm-hmm. Yeah. Yeah. Not a subtract. Multiply. Yeah. Yeah. Multiplying by a factor of, right? So timesing it by -5. So the -5 tells us it's going to go down, and then it's vertically stretched by a factor of 5. So putting it together, so our a value is -5. Okay? Is it okay? Is it safe to move on? Yeah? Yeah? Okay, good. Okay, now letter B, this part here. The point -0.59 lies on a graph of g of x. What are the coordinates of its image graph, B prime, on the graph where it says 4 times g of x? So A is equals to 4. Okay, so starting off with -0.5, comma 9, our image would be x, comma a times y. So it's going to be -0.5, comma 9 times 4, which is 36. Yeah, positive 36. Okay. So this one tells us that there is just a vertical stretch by a factor of 4. So it's 4 times stretchier, 4 times further stretched up. Okay? That's our B prime. So far so good. So that one is just the vertical stretch. Okay. Any questions there? You okay? We're taking baby steps. Good? Yeah, okay. And if there's question, just stop me before it gets confusing here. Now it says here in the next one, given the graph of f of x, sketch the graph of y equals f of 2x. Okay. What does that mean? It's inside the function. So what's affecting here, what's getting affected, it's going to be 2 times the x value. So what does that say? What did we say earlier? Okay, if we go back to our front page, it says here, the B tells us either a horizontal stretch or compression. So if B is between 0 and 1, it's going to be stretched. This is opposite when you're thinking about it, right? And then if it's greater than 1, it's going to be compressed. And if it's negative, it's going to be a reflection over the y-axis. So what does that look like? So going back to this, y equals to, what's the A? What's the A value? The A is on the outside, so it's 1. F of, what's the B value? 2x. So A is equals to 1 and B is equals to 2. Now if B is equals to 2, then there is a horizontal compression by a factor of the reciprocal of this, 1/2. The reciprocal, 1/2. Okay? i.e. 1 over B. 1 over B. Okay? So this is horizontal compression. So let's pick some points and then we'll do the mapping part. I'll just pick these 4 points there. So in this case, we're going to have a vertical compression of 1 by a factor of 1/2. So it's going to be 1/2 times x, and then it's just going to be y. Okay. So y, it stays the same, 0, 4, 2, 0, but then the x will be multiplied by 1/2, so it gets compressed. So it's going to be -2, -1/2, 1, and 3/2, or 1.5. So let's graph that onto our grid here. So the y's didn't change, it's just the x that got changed. Okay, so this is a horizontal compression, so you're horizontally pressing it in this way. Is that okay? take a look at example 5. Yeah. Hey, want to talk to you? Yeah. That's fine. Are you still copying this piece or no? You're good? Yeah? Okay. Good. Take a look at example 5. Oh, this way? I think the vertical stretching and compression and reflection are the easy one. It's the horizontal that's kind of tricky because it's the opposite. It only takes practice to get it better. Is that okay? You got it? Or are you still copying the notes? Okay, sorry. Oh, okay. No, I'm still looking at some people here. Okay, well, I think while we're looking at this one, there's one more thing that we gotta do. It says here, state the domain and the range of this transformed function. What's the domain? The domain of the transformed function. So the new one that we made. -2, yeah. To 1.5, okay, or 1.5. If you want, you can do 3 halves, okay. What's the range? 0 to +4, including 0 and including +4, so we put a square brackets on each end. Good. Okay, next one. Let's see what's going on with this one. Y equals A times f of bx. Okay, I keep writing this down so that we get familiar and familiar and familiar, just like what we did with horizontal and vertical. So what's the A value? The A would be 1. F of, what's the B value? -1/2 x. Okay. Now, that tells us the A is 1, B is -1/2. So that means what? It's going to be a factor of 1 over B, which is 1 over -1/2. That's the same thing as -2. Okay, is everybody okay with this one? Okay, okay. What does that mean? Factor of 1 over B. So put the B in. So 1 over -1/2. Okay, so it's what's 1 divided by -1/2? That's the same thing as 1 times the reciprocal. When you're dividing a fraction, you're multiplying the reciprocal of that, so -2 over 1. So it's going to be 1 times -2 over 1, which is -2. So -2. Yes? So the negative tells us there's going to be a a reflection in the y-axis, right? It flips onto the y. And the 2, it's what? It's a horizontal stretching. So that means there is a reflection in the x-axis and a horizontal stretching as well. By a factor of 2. So the negative tells us it's reflected onto reflected in the y-axis, and then there's also stretching by a factor of 2. So put it all together. So let's do the mapping part of this. Mapping. We love mapping now. Okay, let's pick those nice points in our mapping. Did you see 4 nice points? So 4 nice points would be -3, -3, 0, -2, 1, 1, 2, and then 6, 3. Okay. 2. You could put -2 because it's an absolute value of that. Yeah, you can put the -2. The negative tells us it's a reflection into the other side, right? Reflection this way. So instead of going this way, it's going to be on the other side. Yeah, you could put the -2 there. Okay. So that becomes -2x times y. Okay. So the x's will always be multiplied by -2. Oh, that should be +6. +4, 1. -2, 2. And this one is going to be -12, 3. Okay, which is over my picture, so that's okay. Okay, so now we're going to graph that one. 6, 0. That one. 4, 1. -2, 2. And then the other one is kind of over my picture, over my graph, so it's just okay. So every axis is multiplied by 2, the y is staying the same. Okay, is that good? Let's go ahead and figure out the domain and range of the transformed function. What's the domain first of the new one? So it's from -infinity to +6. Very good. Oop. -infinity to +6. So this one should be round brackets. And then the range is 0 to 0, including 0, so square, to infinity. I'm gonna make this So we're always going to start from the left to right or down up. So negative infinity up to positive 6, including positive 6, and then 0 to positive infinity, including the 0. Okay? Let's try the next one. Okay, we're gonna finish up example 6 and we'll pause and I'll give you some time to work on some questions before we carry on with others. Determine the coordinates of the image points after horizontal stretch or compression. This one is just horizontal only. So initial point, the point is negative 1, 9, lies in a graph of y equals to f of x. We don't know what the f of x is, but we know that it includes negative 1, 9. What are the coordinates of its image a prime on the graph of f of x equals to negative 2x? So that means the b is equals to negative 2, right? So that tells us that there is a what factor is that? Factor of 1 over b. Okay, well, what's 1 over b? Factor of 1 over b, which is 1 over negative 2. So if we multiply something by 1/2, what happens? Does it get smaller or bigger? Smaller. So it got compressed. And then there's a negative there. So that means it's a reflection. So there's a horizontal reflection and a horizontal compression by, if you want to put negative 1/2, that's okay, or you can just go 1/2. So what does that mean? It's going to be, the factor is negative 1/2. So negative 1, 9. After the transformation, it becomes negative 1/2 times x. So it's going to be negative 1/2. Okay, because this is a horizontal 1/2. And the y would be, oh no, positive 1/2 and 9. So negative 1/2 times negative 1, so positive 1/2, 9. Okay, so look at the B. What does the B look like? B is 0.59. Lies on a graph y equals to g of x. What are the coordinates of its image where the graph is y equals to g of 1/3 x? So the B is equals to 1/3. 1/3. Now what factor is that? It's going to be 1 over 1/3, which is 3. Factor of 3. Okay. Now, if you multiply something by 3, does it get bigger or smaller? Bigger. So that's going to be a horizontal stretch. It's stretched by, it's a stretch by a factor of 3. Okay. So this one is horizontal, it's going to be 3 times 0.5 comma 9, so it's going to be 1.5 comma 9. You okay? Okay. Let's do the last one. Oh, is it okay? Yeah. Down a bit?
Just want to double check my answers.
Okay. Yeah, you could put a negative, but I talk about this one here.
The negative one. I just-
Is it okay?
Yeah.
Yeah, okay. Let's do the last one. Let's see where this goes. Read this, Faith. We're on page 12. I'm good. Oh, yeah. Mm-mm. Why did it become 3? Oh, yeah. Say it again. So B is 1/3, yeah. Okay, so you're okay with that one.
Our x value multiplied by 1/3, our x value.
Oh no. For this one here, our x value will be multiplied by a factor of 1 over b. 1 over b. So let's take a look. So over here, it's going to be multiplied by a factor of 1 over b. So when we have a 1/3, so if let's say b is equals to 1/3, we're going to look factor of 1 over b, which is 1 over 1/3. And then if we do 1 divided by 1/3, that's the same thing as 1 times the reciprocal, so 3 over 1, which is 3. So the factor is 3. Even though the b is 1/3, the factor is a factor 3. Yeah. So that's a
Just direct, we go into the equation, that's all.
oh, the equation, yes, yeah. Yeah, that's the one that's a little bit different. The vertical one's perfect, right? You just multiply it the way it is. Okay, now this one here, example 7, and then we're gonna kind of rest and kind of digest this what we just finished. Okay, so let's say here, example 7, given a graph of y equals to h of x. Sketch the graph of y equals to negative 1/2 times h of 2 of x. So what's our a value? Our a value is negative 1/2, okay, negative 1/2. And what's our b value?
2.
B value is 2. So that, what does that say? What does that say? The negative tells us a vertical reflection in the x-axis. Okay, so vertical reflection in the x-axis, so it's like flipped down. And the 1/2 part of that just tells us a vertical compression of a factor of 1/2. Okay, so the negative just talks about the vertical reflection. The 1/2 talks about the vertical compression. Now what about this one? We can't just take it the way it is from the equation, because the b has to be a factor of 1/b. So in that case, factor of 1/b. Okay, well, what's 1/b? Factor of 1/2. So because it's 1/2, if we multiply the x by 1/2, it's going to be compressed horizontal compression of 1/2. Okay? So b is 2, but the factor is 1/2. Is that okay? Is that better? B is 2, but the factor is 1/b, which is 1/2. B is equals to, but the factor is 1/b. So 1/2. So we're multiplying by 1/2. Good? So let's put it together. So x times x comma y. So the x is the factor of 1/2 that's being multiplied to the x. So it's 1/2 x. And then the y would be multiplied by negative 1/2. Let's see, what kind of numbers do we get here? So how many points do we have? 1, 2, 3, 4, 5 points, original points, and then this is our map. Okay, so the x coordinates are being multiplied by 1/2, and then the y coordinates are being multiplied by negative 1/2. So I'll start with the x's so that I don't go back and forth. It's going to be negative 1.5, negative 1, and then the y's would be negative 3, negative 5, negative 7.5, negative 5, negative 1.5, and negative 3. So we're compressing everything and then reflecting on the y. So negative 1.5, negative 3. Negative 1, 7.5. Negative a half, negative 5. 0, negative 1.5. And then a half, negative 3. So that looks like this.
So it flips it.
It flips it, yeah. Negative 1.5, negative 3, negative 1, negative 7.5, negative a half, negative 5, right there. 0, negative 1.5, yeah. It flips it because of the A being negative. Vertically flips it.
So it's like a mirror.
Okay. And it got compressed. Okay.
Because of the y, right? It would be-
Yeah. Everything is multiplied by a half. So if everything is multiplied by half, it gets smaller. So it gets compressed. Okay. I'm stopping right there for now. This is something that we can't rush.